You're holding a fossil in your hand, or rather, you're staring at a gap where a fossil should be. 5 million years ago, something happened to our ancestors. Their brains started expanding at an unprecedented rate. Not gradually, mind you. Rapidly. In geological terms, almost overnight. And then you reach into the record, expecting to find the intermediate steps, the evidence of how this happened, and there's nothing. A blank stretch of rock. A void where the story should be. This is the unsettling reality of human evolution. We have this grand narrative about natural selection, adaptation, and gradual change. We understand it in theory. But when you actually look at the fossil evidence, at the genetic data, at the archaeological record, you find yourself staring at a series of leaps that don't quite add up. Scientists will tell you we're filling in the gaps. And we are, slowly. But here's what they don't always emphasize. Some gaps are wider than we'd like to admit, and what we do know raises questions that current frameworks struggle to answer. The story of how humans became human isn't a smooth incline. It's more like a staircase with some steps missing, and we're standing on the landing, trying to figure out which way we actually climbed. Start with something basic. Your brain is approximately 3 times larger than a chimpanzee's. We're not talking about a 10% difference. We're talking about a 3-fold expansion of one of the most metabolically expensive organs in nature. Growing a human brain requires an enormous investment of biological resources. An infant's brain alone consumes about 20% of the body's energy. That's oxygen, glucose, everything. So here's the practical question. Why would evolution keep doubling down on this expensive structure? What selective pressures were so intense that they demanded we build brains that barely fit through the birth canal, that made childbirth exponentially more dangerous for mothers, that required children to be helpless for years after birth? The conventional answer invokes hunting, tool use, social cooperation, problem solving. All plausible. All probably true. But the timing is where things get weird. The fossil record shows that brain expansion didn't happen linearly. It happened in clusters. Around 2.5 million years ago, you see a significant jump. Then things plateau. Then another jump around 1.8 million years ago. Then another pulse around 600,000 years back. Each time, there's an acceleration that outpaces what you'd expect from incremental selection. It's almost as if environmental pressures suddenly increased, then decreased, then increased again. Some researchers point to climate cycles, periods of intense environmental instability that would have favored cognitive flexibility. Others suggest that the arrival of new tools created new selection pressures. But there's a gap between the tools appearing and the brain expansion, and we're still not sure which was driving which. What makes this genuinely strange is that bigger brains don't automatically translate to more advanced behavior. Neanderthals had brains that were actually larger than ours. Yet something about modern human cognition, something subtle and chemical, allowed us to outcompete them. We made art they didn't. We made boats. We developed symbolic language in ways they apparently didn't. We created myths. We asked questions about why we exist. Neanderthals hunted, made tools, cared for their injured. They were intelligent, but they weren't us. And the difference isn't captured by brain size alone. It's something about the organization, the connectivity, the way patterns form in the neural architecture. Scientists have theories about this. Differences in frontal lobe development, variations in how the brain connects sensory information to abstract reasoning. But we're still explaining the mechanism of something we don't fully understand. Then you hit the language problem. Language isn't just a communication tool. It's a specific technology for encoding abstract concepts, for creating chains of logical reasoning, for representing things that don't exist. No other species does what humans do with language. Animals communicate. Whales sing complex songs. Dolphins have signature whistles. But they're not creating syntax. They're not embedding clauses. They're not telling stories about the future or debating philosophy. Somewhere between 400,000 and 100,000 years ago, something shifted. The archaeological record gets suddenly richer. You start seeing evidence of symbolic behavior, ochre with intentional patterns, carved ivory, shells that traveled hundreds of kilometers from their origin point, suggesting trade networks. Burial sites appear with grave goods, implying belief in an afterlife. This clustering of symbolic behavior happens relatively quickly, geologically speaking. It's called the Upper Paleolithic Transition in Europe, though similar patterns appear in Africa and Asia around the same time period. But here's what doesn't add up. We find no obvious neurological or genetic change that corresponds to this shift. Humans around 100,000 years ago had modern anatomies. They were us physically, yet their behavior was fundamentally different from humans 50,000 years ago. The gap isn't in our bodies. It's in what those bodies could suddenly do with information. Some researchers argue that a single genetic mutation, possibly in the FOXP2 gene, which relates to speech and language processing, might have enabled the whole cascade. But FOXP2 variants appear in our fossil cousins too, suggesting it's not the simple answer everyone hoped for. Others propose that it was a cultural threshold. Once you had a certain density of symbolic users, language became self-reinforcing and everything accelerated. Plausible. Difficult to test with fossil bones. This is where it gets genuinely disorienting. We can point to environmental changes that might have triggered it. Ice age pressures. Coastal migrations that exposed humans to new food sources. The rise of ochre-using, symbolic thinking populations in Africa. We can build narratives. But the physical evidence doesn't show us the threshold being crossed. It shows us already on the other side, wondering when we got here. Then there's consciousness. Now, consciousness is tricky to define, let alone measure in fossils. But we can look at proxy measures, self-awareness, theory of mind, the ability to imagine things that aren't present. When did humans develop these capacities? When did your ancestors start thinking about themselves as separate entities with internal mental states? When did they realize that other individuals might have beliefs different from reality? These seem like prerequisites for complex social coordination, for maintaining stable groups larger than immediate family, for developing moral systems. We know that something like this happened because we have evidence of it in behavior, cooperative hunting on massive scales, elaborate social hierarchies, ritual practices. But we can't point to a specific moment, a specific adaptation and say, this is where it started. And we can't fully explain why it happened in our lineage and not in others. Elephants are intelligent. They mourn their dead. Dolphins have complex social structures. Primates understand hierarchies and coalition building. But humans are the species that internalize their social world into abstract principle that created laws and systems and ideologies. And the genesis of that capacity vanishes into the geological record. Some researchers have pointed to the evolution of childhood as crucial. Humans have an extraordinarily extended juvenile period. We're dependent for years, learning constantly. That's metabolically expensive, evolutionarily risky. But it creates opportunity for cultural transmission in a way that faster developing species can't match. A human child absorbs thousands of hours of accumulated knowledge. A chimpanzee does too, but the sophistication and abstraction level are different. Somewhere along the line, that extended childhood became fertile ground for symbolic thinking, for the internalization of culture. But when? And what triggered the extension of childhood in the first place? We have candidate answers. Climate instability that made it advantageous to have more flexible, adaptable offspring. Tool complexity that required longer training periods. But we're explaining a gap with a theory that itself has gaps. The deepest mystery, though, might be consciousness itself, Not consciousness as awareness, but consciousness as the specific human form of it. The experience of being a self observing its own thoughts, creating narratives about its own existence, projecting into imagined futures, contemplating its own mortality. This isn't unique to humans, but the intensity and sophistication of it is. We're the species that knows it's going to die and has decided to obsess about it. We create meaning to fight against that knowledge. We develop religions and philosophies and sciences to explain the unexplainable. This entire capacity seems to have emerged relatively recently, and its neurological basis is still mysterious. Now, here's where skepticism becomes important. Some of these gaps might not be gaps at all. They might be artifacts of our perspective, things that look mysterious only because we're looking at them wrong. The fossil record is incomplete by definition. Soft tissue rarely preserves. Behavior leaves traces only if you know what to look for. We might be mystifying perfectly explainable phenomena just because we can't see every intermediate step. And science has been filling in many of these blanks. Genetic research has revealed that modern humans interbred with Neanderthals and Denisovans, picking up mutations that may have affected immune response, cognition, and metabolism. Archaeological work in Africa has pushed back the dates of symbolic behavior further than we expected, suggesting that the emergence of modern behavior was more gradual than the European record implied. Neuroscience has identified specific neural structures and connections that distinguish human cognition from that of other primates. But there's a difference between filling gaps and explaining the fundamental transitions. We can identify candidate mechanisms, but we still don't fully understand the causal chains. Why did one cluster of hominins develop complex symbolic language while another, equally intelligent species didn't? What exact combination of circumstance and genetics produced the particular form of consciousness that asks questions about its own existence? These might not be mysteries forever. Science tends to solve mysteries, not because they're inevitably solvable, but because the questions drive research. The real issue is that evolution is a process without intentionality, without goals. It doesn't build toward anything. It responds to pressure. And yet human evolution looks, in some chapters, almost like something was building toward us, like the leaps were directed. This is an illusion. It's called the perception of design, and humans are excellent at finding patterns even where none exist. But it's an understandable illusion. Brain expansion, language emergence, symbolic behavior, the construction of abstract systems of meaning, these all point in a direction. They suggest development. And that perception is powerful, even when you understand the mechanism that creates it. What these gaps actually reveal is that our standard models of evolution, models built around incremental change and constant selection, struggle with punctuated equilibrium, with rapid transitions followed by stability. They're uncomfortable with the role of chance and circumstance in creating the preconditions for innovation. They want to find the environmental pressure that explains each feature. But sometimes the explanation is more circular. The environment changed, some variation was available, and it happened to be useful. The chain of contingency is too long to fully reconstruct. Understanding this has implications beyond evolutionary biology. It tells us something about change itself, about how systems develop new capacities. Organizational change in human systems often looks similar, long periods of stability punctuated by rapid transformation when preconditions align. Technological development shows the same pattern. Language evolution in real time shows it. The gaps in the evolutionary record might be telling us that jumps, discontinuities, rapid transitions are actually normal for complex systems. We expect linear progress because that's how we tell stories, but reality often produces leaps. The reason these gaps matter isn't just academic curiosity, though that's valid. Understanding how human consciousness, language, and symbolic capability emerge gives us insight into what we actually are. We're the product of a contingent process, shaped by pressures we don't fully understand, with capacities we're still working to explain. That's not a comfortable position. We'd prefer a clear story of progress, of improvements, of rational development. But the evolutionary record suggests something more disquieting. We're the result of accidents, cascading circumstances, random mutations that happen to interact productively with specific environments at specific moments. We shouldn't exist at all. And once we did, we created systems of meaning to convince ourselves that the story makes sense. The gaps in human evolution aren't failures of science. They're invitations. They're places where we can honestly say we don't know, where we acknowledge the limits of our frameworks, where we admit that the story is far stranger and more contingent than we'd like. And in that admission might be more insight than in any confident explanation. Because understanding that we're not the inevitable product of a rational process, that our consciousness and language emerge from accident and opportunity rather than inexorable design, changes how we think about what we are and what we're capable of becoming. That realization sits deeper than any fossil. It lives in the gap between what we are and what we think we should be.